and frequency as separate things, and Theravibe is one of the only models that you can actually adjust the force independently. So let me talk a little bit about how that works and how the controls are used to adjust that. Theravibe has a couple of different programs. Some of them are preset where they go through a range of different frequencies and force intensity, and it has a manual mode as well. So in the knob on the panel serves different functions depending on what you're doing. When it's running through one of its preset programs, the knob adjusts the overall level of that, the overall level of force, because it's like a tune, I suppose, if you want to think of it that way, that the force changes up and down a little bit all the way through that 10-minute program, and then what the knob does is it lifts or raises that overall force level. So notionally it's a lot like a volume control if you think of it that way. But the one key thing where Theravibe is different is if it's set on level 4, then it's going to produce the same vibration regardless of the weight of the person standing on the plate. And then in the manual mode, it's possible to adjust the frequency and the force independently. And this is a key differentiator with the sonic type of technology, with the linear motor technology compared to all other vibration plates. So with Theravibe, you can adjust the force in units of gravitational acceleration. So from 0 to 1g of force is where we limit it. And you can adjust that from a point where it's just barely perceptible in very, very small increments, like a volume control. So just to give you an idea of what that G-force means is at a setting of 1G, you're being lifted, it's lifting you with the same force that gravity pulls down on you, pulls you towards the floor. And at a low frequency like 5 hertz or so, if you're at 1G, as the plate reaches the top of the vibration and starts moving away, you just feel like you're lifting off the plate, just a fraction of that lightness. Going over 1G, you would actually be momentarily weightless and falling a little bit behind the plate. The problem with that is when the plate hits the bottom of the vibration and turns around and starts moving back up again, you're still traveling down, and then of course you collide with the plate with the bottom of your feet, and that gives you some jarring sensation, which is obviously not very comfortable and not very healthy. So that's one of the reasons why we limit the force to 1G. Also, just to stay within the recommendations of the ISO standards guidelines, which we discussed earlier. And then Theravibe also allows the frequency to be controlled independently, because the motor is a linear motor, and it's traveling back and forth exactly like the plate. So the linear motor itself is coupled directly to the plate, and any movement on the plate is exactly what's happening at the motor. And that's unlike any other vibration plate. What it's doing is it's translating rotational movement, so the spinning motor, into some linear movement using a crank or a weight or an offset weight. And so Theravibe's linear motor produces a straight up and down force on the plate, and so our plate moves purely in the vertical direction, in the Z direction. There's no sideways or back and forth movement. And the movement of the plate is monitored, and that information is used to adjust the power to the motor. And so that's something that's very unique about Theravibe, is the plate position is measured very, very accurately. It's about 1/10,000th of an inch, and that happens over 1,000 times a second, that it measures that and dynamically adjusts the power to the motor. So with a linear motor, there's an alternating current to the motor, and that produces an alternating force, which is the vibration. So with a linear motor, if the current is increased, then the resulting vibration in that motor is of greater amplitude or more force. So it's a stronger vibration. And if the current is alternated more rapidly, then the frequency of the vibration increases. And that's quite different to a rotary motor, which is the kind of technology that powers every other platform, where you really only have one control, and that is the power to that motor, which is going to affect its speed. You can't make the motor stronger or weaker in terms of the vibration that it produces. So back to the linear motor design, more current into the motor, more alternating current means more force, faster or slower alternating current changes the frequency. So in this way, the two parameters, which are really important, the force and the frequency, can be varied independently. And so why is this necessary? Well, different parts of the body respond to different frequencies. So it's necessary that we, as a therapeutic device, want to be able to adjust the frequency to target a particular area. But the force must also be adjustable at any frequency in order to find a setting that matches the condition of the person using the machine. So Theravibe is a therapeutic device. It's not while you can use it for exercise, it's not designed to be used exclusively by top-level athletes. So we have people that use the machine, some that can barely walk, various levels of impairment. They might be recovering from injury, so we need to be able to reduce, or we need to be able to set the force level where it's comfortable and safe for them, but at that level we still want to be able to change the frequency to whatever we want. So that's one of the key benefits of this linear motor technology, that we can vary those two things at the same time. Now, it's a common misconception that other vibration plates have a force or amplitude control. That's entirely inaccurate. What it is, in effect, it's just a frequency control, but due to the way that these platforms are designed and built, when you increase the frequency, as a consequence of doing that, the vibration becomes stronger, and reducing the frequency makes the force weaker, but you're still not doing those two things independently. So it's not possible with other vibration platforms to have high force of vibration, high amplitude of vibration at low frequency, or low force at high frequency. That's just not possible with a rotary motor powered device.